Section 5.4, you can see our wonderful objectives up here. We're going to divide polynomials using long division. That'll be it today. That's going to be what we get through. And polynomial long division is one of those things you have to learn, you know. There are only certain polynomials that we can, it's almost like a shortcut, divide synthetically. And so this is a skill we have to have. We're using it in pre-calculus right now to find zeros and all that good stuff. So tomorrow we'll talk about dividing polynomials using synthetic division, which is very, very cool. All right, our essential understanding is you can divide polynomials using steps that are similar to long division that you learned in grade school, you know, long division. Literally every year I have somebody that comes up after I teach this lesson and says, I never figured out how to divide with long division in grade school. And my teachers tried to show me how to do that. I just never got it. But with polynomial long division, it's a little bit different, and so usually you start to catch on to it. The steps are very similar. So when you try to factor a polynomial, you are trying to find a divisor of the polynomial that gives a quotient, the other factor, and a remainder of 0. We're trying to find the numbers that will divide into this nicely. Those numbers are factors. Those are the nice ones that we've been factoring. But in that last problem that you had me solve by graphing, we don't have the ability to factor that. It was an x cubed, and then it had an x squared, and then it had one number in the back. It's like, I haven't done anything like that before. I don't know how to factor that. Well, we don't give up. You know, those are the rules. The rules are no crying in math, and we never give up. So we use other methods to figure out what could we try. Now, this suggests being able to divide one polynomial by another can help us factor. It absolutely does, and that's what we want to do. So numerical long division and polynomial long division, very similar, not just similar, very similar. So if we have 21, and we're supposed to put that into 672, here's what we don't do. We don't sit there and think, oh, I wonder how many 21s will go into 672. Well, let me take a crack at it. Let's see, would 9 of them fit in there? And you know, we just don't do that. What we do is, instead, we think, let's go by position of the numbers. So I check to see, is 21 going to go into that first digit? Well, no, it's a 6. That's not going to happen. Move over one digit. Will 21 go into 67? Yeah, that'll happen. So you sit there and think, well, how many times? Let's see, that'd be times 3, so 63. That's going to be as close as I can get. So I'm going to put a little 3 up here because at that digit, if I take 3 times 21, I get 63, and this is going to work. And then what do we do? Subtract. Yeah. Nobody said change the sign and add, but that's really what we're doing. We're changing the sign and we're adding when we're subtracting, because that's the definition of subtraction. So we subtract that and we get a 4. Now, 21 won't go into 4. We're done? What did you do next? Bring down another digit. So you bring down the 2. And you realize, oh, that's going to work really nice because 21 times 2 is 42. And I change the sign and I add remainder of 0. That means that 32 went into our 672 perfectly. 21 went into 672 perfectly. These were factors of 672. Now, remember, we did not focus on the whole number at one time. We focused on the first digits that we could match. That's what we were doing, because that's what we do with polynomial long division. So down here, we're going to jump right into this today. Objective, remember what you did with long division before? Here's a polynomial. Now do it. Well, here's what we're going to do. We're going to write it the same way. 2x plus 1, division symbol, 6x squared plus 7x plus 2. We're going to see what happens. But the difference is, when we have a polynomial out in front, our focus is on just making the first term match. The other stuff is just, it's going to happen. Just like when we did subtraction before and we had something that we had to bring down and keep working with. So I have this 2x plus 1. And I have to get my 6x squared gone. That's what I'm doing. I'm trying to get rid of a digit. So I'm trying to get rid of 6x squared. And I think, well, that would take multiplying by 3x out here. But if I multiply the 2x by 3x, I have to multiply everything in the parentheses by that 3x. So that's what I have to do. So 3x times 2x is 6x squared, but because of the multiplication process, I'm also going to get plus 3x back here. Now I always check. Did that do what I wanted it to do? Did it give me a perfect match in that first term? Sure it did. So this 3x should go right up here over the other x term. And now we want to change the signs and add. That's a really important part of polynomial long division. In grade school, they just said subtract. But with these, especially when they get complicated, we want to change the signs and add. And again, what we hoped would happen, happened. The x squareds are gone now. Not going to have any more x squareds to deal with. 7x minus 3x is 4x. And just like we did when we were doing the normal long division with numbers, we're going to bring the 2 down. We bring that next digit down. Now I go back over to my 2x plus 1. And my focus is on getting a 4x in that first position because I want to tackle this term by term. Well, that's not a big deal. I just multiply this by 2. That'll give me 4x. So 2 times 2x is 4x, but 2 times 1 is 2. It did its job. It's a perfect match. I'm going to put it up there above the 1's digit, which is a plus 2. And now all I need to do is change the signs and add. Hey, no remainder. So this means 6x squared plus 7x plus 2 could have been found by factoring or foiling those two because it worked out perfect. No remainder. If we multiplied these two back together because they are factors, we would get 6x squared plus 7x plus 2. So, very similar to normal numerical long division. So now what? Well, we need to do more. We need to get good practice at this. Because the remainder for each of those was 0, they were factors of the dividend. So 21 is a factor of 672. There's no remainder when we divided that out. 2x plus 1 is a factor of 6x squared plus 7x plus 2. Are all of them going to go in perfectly? That's not reality. We will have remainders from time to time. So we can divide a polynomial p of x by d of x and get a polynomial quotient q of x and answer quotient. And the polynomial remainder r of x. So if we wanted to get the polynomial back, we would take our divisor and our quotient and we would multiply those together and then we'd add the remainder. And that's exactly what you do. Remember in the last one we didn't have a remainder, so we said if we multiply these two together, we'll get back to the original. That's what we do. If r of x is 0, then p of x equals those two polynomials multiplied together because you don't have a remainder. It came out to be 0 and they're factors. To use long division, p of x and d of x should be in standard form. That's because of the placement of our terms. We want this in standard form. And they, like it says, should have 0 coefficients where appropriate. So if there's something that's missing, like if we have x cubed minus 85, we're probably going to want to put x cubed plus 0x squared plus 0x minus 85 just to hold the places for those. And this process stops when the degree of the remainder is less than the degree of the divisor. So if you can't multiply by something to reduce the powers, which we can't, then we stop. So, this little bugger. Using polynomial long division, we are going to divide 4x squared plus 23x minus 16 by x plus 5. Use polynomial long division to divide 4x squared plus 23x minus 16 by x plus 5, and then they want to know what's the quotient. What do we get up here on the top? And then if there's a remainder, what is it? All right, so I'm starting over here with my little x plus 5, and I have to get rid of a 4x squared. So what am I going to multiply this with to make that happen? 4 and x. 4x squared plus 20x. It did its job. 4x squared and 4x squared are a perfect match, so I'm going to put that little 4x right up here. And then I'm going to change the signs and add. What should I do next? See, you all were groaning when I said long division earlier, and now you can't stop yourselves. I see this. You're all heads down and you're doing these. See, it's catchy. It's what it is. All right, back to our x plus 5 then. What are you doing to the x plus 5? It's working for us. Put it up top. We'll change the signs. And we'll add. Now, we've got a negative 31. Can we multiply x plus 5 by something to make it negative 31? No, that's what they were talking about where you're paying attention to the powers, you know. We needed at least an x to the first so that we could divide x to the first into it. So it's like, okay, how do we write this? Well, they wanted to know the quotient. So the quotient is the 4x plus 3. And our remainder is negative 31. But we will never write our answers that way. That's like way back when you first encountered remainders with long division, they had you write that. But what we would write would be 4x plus 3. And then tack your remainder on in the back, minus 31, over the divisor. Remember how you always had to use that piece as a fraction at the end? So that'll be over x plus 5. So we'll have 4x plus 3 minus 31 over x plus 5. And that would be the proper way to write it. Yes, just like your book did up and down for end behavior, we are going to ignore the fact that in the back of the book they do capital R, negative 31. It's just silly. So we're going to write it the correct way, like it's supposed to be. So now they're saying, do you realize that this is checkable? Well, it better be, because if it's not, then you're not going to know whether or not you did it right or wrong. So what we would do is we'd take our x plus 5 times 4x plus 3, see what we get, and then subtract that remainder of 31. And we'd better get back to the original. So if you do FOIL on these two, you get 4x squared plus 3x plus 20x plus 15. And then we're still going to subtract our 31. And once you do all of that math, you get 4x squared plus 23x minus 16 plus. And we know we're right. So definitely checkable. All right. So for people that were groaning about long division, you seem to be doing just fine. So it would be a good morning for a candy partner, I believe. So go ahead and get started on that while I get you a partner. By the time I had the candy, it passed out. You know, most people had this one done when I was wandering around. And what is going on with this remainder? Tell your partner, what's going on with this remainder? Don't get one. We don't. So that means these are both factors of 3x squared minus 29x plus 56. That means if we pulled them back together, x minus 7 times 3x minus 8 would get us that original, it's called a dividend. I should remind you guys of all the vocab stuff for these, so when we talk about them and you're saying, no, I made a mistake in the, this is called the dividend under here. This is the divisor, this is the quotient, and then this, of course, is our remainder. So when we get a remainder of 0, that's a big deal. You know, that means this was something we could have factored if we had to. It wouldn't have been the most pleasant experience in the world, but we could have factored it if we needed to. And that's important because that's how we find additional zeros. You know, we always want to get things down to where they can be factorable if they are. So on the next page, their question is not divide, blah, 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 it is x squared plus 1 a factor? How are we going to know?
Divide.
Divide it. So, divide it, check with your partner, see what you get. Why is this one different? X squared in the front. Oh man, that just messes up the words, doesn't it? So, what did you do first? 3x squared. Made you happy. 3x to the fourth. But not so happy? Plus 3x squared. Well, we can't put that here. This is an x to the third term. We gotta go over here. But it did what it was supposed to do. It got rid of that first term for us. We're going to put it up here. And we're going to change the signs. We're going to add. Do you suppose we just ignore that negative 4x to the third?
No.
That. We're going to bring it down. Put it there. Now we might also need the 5. So we might as well bring it down now instead of realizing in a minute or two that, yeah, we're still going to need 5. So we start back over here. What are we going to multiply by to get rid of that first term? Oh, I'm sorry. Positive. Put the wrong sign. There we go. What are we going to multiply the x squared plus 1 by? Negative 4 and an x. So negative 4x cubed does exactly what it's supposed to do in the front, but then things get kind of weird again. We go negative 4x plus 1, that's going to be negative 4. I don't have an x term over there. And that's why they said, when you set these up, if something's missing, just so you don't get all weirded out, you might want to put in a 0 for it. You know? Otherwise, you start thinking, did I mess up on something here? You wouldn't have to. I mean, if you're really organized without it, you wouldn't have to do that. But now we know that negative 4x times 1 go over there. Did what it was supposed to do. So we'll put it up there in that spot. It'll be gone when we change the signs. But now we have a 9x squared plus 4x plus 5 to deal with. Back over to the left. What are you going to multiply that by to get rid of that first term? 9. 9x squared plus 9. And again, we don't like it because it doesn't line up like where it's supposed to line up, but 9x squared. It's 9. It's doing its job. Back down here, change the signs, and add. Can we go one more time? What's wrong? So we have an x squared, and we can't make that an x. With multiplication, we can't make that an x. So is this a factor? No, that ugliness over there, that's our remainder. This is not a factor. We had a remainder. It wasn't a remainder of 0. So this one got a little dirty on us because of that. X squared plus 1 in front there. So is it a factor? No. Took some work, but we saw that. So the thing that's important here is going to be if anything's missing, and it did mess with some of you, I saw that. Not all of you. Some of you were able to keep track of everything without those zeros in there. But if something's missing, we're going to want zeros. Yep, both.
I just had a question. How Where did the 4x come from? Like at the end.
Oh, remember in this step, we had a negative 4x plus 1 that gave us a negative 4x, but then you change the signs and add. And then we have to bring down anything that we haven't worked with yet. So we're still adding. It's like we're adding nothing to it because there wasn't anything. When we did our multiplication, there wasn't anything to line up with it. So you just keep bringing it down and you keep working with it. So this is where it gets a little different than long division with normal numbers. Look at this little bad boy here. X minus 2. That's missing a boatload of stuff. Is it a factor? Yes or no? If not, then write it as a factor. If it does end up being a factor. So if it's not, we're just going to write not a factor. But if it does, then we put that in there. So 43210. Based on that last problem, because we went over it now, where do you think you're at? If I should just let you work on this with your partner. Okay, number's too low. Let's do this one together. Alrighty, number's too low. All right, we've got x minus 2. How are we going to get x to the 5th? What goes on here? There we go. X to the 5th minus 2x to the 4th. That's a little better because they line up. You know, we like that. They line up. It worked. Put her up there. Change the signs. And the x to the 5ths are gone. Bring down that next 0, and there's a lot of them. Back to x minus 2 in front. What are we going to do to it? Got it. We need it to be 2x to the 4th. So 2x to the 4th. And then minus 4x to the 3rd. Our little 2x to the 3rd did its job. So let's put it up there. And then let's change the signs. And add. Down the next term. A whole lot of zeros to keep track of. Now we're back at our x minus 2. What are we going to use? Certainly will, because that'll give us our 4x to the 3rd. Also gives us negative 8x squared. But it worked, so let's put it up here. Change the signs. And add. We have an 8x squared. What should we multiply by? Oops, getting ahead of myself. I'm writing down the answer already. That'll give us 8x squared. It will also give us minus 16x. It's just a byproduct. It happens. Change the signs and add and bring down that minus 32. Back over here at x minus 2. What do we need? What should we multiply by? 16. And we notice success. Because when we change the signs and add, 0. So what on earth do we put? What do we put? It said, is it a factor? Yes. And we're going to write it as a factor. So our x minus 2 times our big enormous answer there, which was x to the 4th plus 2x to the 3rd plus 4x squared plus 8x minus 16. Found one. We found one. We could find a 0 with this. We could say it's 2. Now,
Wait, is it a positive 16?
oh, thank you. I'm getting this part over here in my head. We've got that up there, and I'm sure we're running short on time, aren't we? Rats. Okay, so thank your partner for the wonderful help.
Thanks.
And I think because we talked through problem 2A, that the got it would just be repetition anyway. All right, so I got a statement, and I want you to 43210 me on the statement. This isn't hard, but I have to keep track of things. On your agreement with that statement, 43210. This isn't hard, but I need to keep track of things. Yeah, organization is going to be the key, you know? So, done PLC schedule.
No worries.
Here we are. They're not all going to be atrocious.